So while you're writing it down, Chapter 2, most of what Chapter 2 is linear equations. Linear equations are extremely important. They are the basic beginning equations, basic beginning graphing that you do in algebra. They are extremely important. Okay? You can use linear equations for a lot of things. My calculus students, we use linear equations to analyze very complex curvy equations. The idea is that if you zoom in close enough on any kind of a curve, it becomes a straight line. So that's what we do. We do an awful lot of that. Important parts, slope. The slope of vertical change is the ratio of the vertical change over the horizontal change, i.e. rise over run. How much you go up over how much you go over. Linear function is a function that graphs as a straight line. Linear equation, a representation of a linear function, such as y equals 7x plus 4. Hey, as long as I've got x, and I've got y, and I got a bunch of numbers and an equal sign, I've got a linear equation. They are not always, will not always be in mx plus b form. And that is the easiest one to graph from, but that's about it. Okay. Y-intercept is the point 0, y. That is the point where the line crosses the y-axis. That is an important place where it intercepts the y-axis. X-intercepts are also important, probably more important. Y-intercepts we use for graphing because it's easy to graph straight lines using y-intercept. Everything else, we talk about the x-intercepts. X-intercepts are where it crosses the x-axis. X-intercept are our zeros. X-intercepts are our roots. X-intercepts are the things we spend an inordinate amount of time trying to find. You have one x-intercept with a line. You have several of them when you start getting all curvy. Those are extremely important points, the x-intercepts. More important, I dare say, than the y-intercepts. Slope-intercept form, y equals mx plus b, where m is slope and b is y-intercept. Great for graphing. For everything else, it's all right. Questions from this first page? Once again, it's not like you haven't seen this before. Okay, formulas. Muy importante. You need to know these formulas. You need to have them down. Slope is rise over run. It's the m in mx plus b. It's if you have it in standard form, it's minus a over b. This is the one you're going to be using. You're going to use this today. You're going to use this a lot. This is important. It's the one that also gets screwed up the most because they're not paying attention. It's y over y. It's y minus y over x minus x. Here's what happens, though. When I have a coordinate, your coordinates appear not in yx. Your coordinates are x, y. So students go, oh, it's x on top. It's x first. It's got to go on top. No, it doesn't. The x's are on the bottom, and that's the most common error. Okay, the most common error. You have to remember it's y on top, x on the bottom. It's rise over run. You rise up and down. What goes up and down, your y's go up and down. You run back and forth. Your x's go back and forth. Rise, y's. Run, x's. All right, remember, you run back and forth, and x goes back and forth. You rise up and down, y's go up and down. Y's over x's. Have to remember that. mx plus b is the equation in slope-intercept form. Like I said, this is great for graphing. We're not actually graphing today, but this is great for graphing. Okay. Now, so write an equation of a line with each slope and draw the graph of a line with each slope. Positive slope. Okay, for example, y equals 2x minus 5. And that might look something like that. The idea is as I'm right, if I am rising, as I go from left to right, we always look at everything in here as we go from left to right. If I'm going up, it's a positive slope. A negative slope. Y equals negative 1/3 x plus 1, which might look something like that. And that's close enough for what we're doing in here. So I don't have flashes and graphing purposes. Negative slope, it goes down as I go from left to right. This ought to be an idea when you're graphing a line. If your slope is positive, it better be going up. Your slope is negative, and I say graph a line, and the slope is negative, it better be going down. They better match. That's a clue to graphing things correctly. A zero slope. Okay, a zero slope means the slope is zero, which means it does not go up or go down. It is flat. Zero slopes are y equals some number. If you have no x value, it is a zero slope. It is a flat horizontal line going through that point on the y-axis. Undefined slope. And there's a difference between zero and no slope. Undefined slope is also the same thing as no slope. And zero does not mean no slope. They're not the same thing. Zero slope and no slope are not the same. Zero slopes have no slope to them. There is no run. There's only a rise. And these are always x equals some number. If it's x equals some number, there is no y coordinate. It has an undefined slope or no slope. Questions? Okay. Find the slope of the line passing through the points. This is the one where we're using change in y over change in x. Your formula will always look like that with blanks filled in. It will always start like this with the blanks filled in. They all look the same to begin with. You're just filling in blanks on the formula. On the top, go the y-coordinates. Does not matter which y-coordinate comes first. Either one, doesn't matter. 7 minus 4. It only matters which x-coordinate in the denominator comes first matches which y-coordinate came first in the numerator. I used 7 first. I must use the corresponding x, which is negative 3. Always, always, always just plug things in before you simplify. If you don't plug them in and you start doing it in your head, you'll screw it up, because that's what everybody does that tries to do all this stuff in their head. Write it down first and then simplify. So 7 minus 4 is 3. Negative 3 minus, that's negative 3 plus 2, which is negative 1. So I get negative 3. That's my slope. Because if you start doing, minus negative 2, that's plus 2, and you write it down as plus 2 rather than changing it like I did, next thing you know, you're going to be doing addition on all of them. Because that's what happens every time. I'm doing this 20 freaking years, and I see the same thing. When kids get lazy, they start making regular mistakes. Because they got lazy. And it's not that much more to put minus, and then put minus and negative, and then fix it a little bit later rather than trying to do it all in your head because you're lazy. And you make mistakes. Okay. Same thing, I can put either one of my y-coordinates first. They both just happen to be the same thing. 1 minus 1. And then, negative 4 over 3. I'll use the second y-coordinate. I'll put the second y-coordinate first. So I put the second x-coordinate first. You can tell that I used the second y-coordinate, right? As opposed to using the first y-coordinate. Doesn't really matter, because they're the same. So I have 0 over negative 7, which is 0. I can have 0 in my denominator. Cannot have 0 in my numerator. I cannot have it in my denominator. 0 in my numerator is 0. Okay, let's say negative 3 minus 1 over 7 minus 7. Negative 4 over 0 is no slope. I get 0 in my denominator. If you get a number over itself, 3 over 3, negative 5 over negative 5, that is 1, with one exception. 0 divided by 0 is not 1. 0 divided by 0 is undefined. It is if you have 0 in your denominator, it does not matter what's in the numerator. It's undefined. Okay? Irregardless what's in the numerator. 0 in the denominator, nothing in the numerator. Your turn. Okay, first one, slope is y minus y, 4 minus 1, over x minus x, 5 minus 9. So I get 3 over negative 4. That's good enough, negative 3/4. Second one, slope is y minus y, 3 minus negative 4, over x minus x, which is 7 over 0. So this one's a no slope. Last one, my slope is 6 minus 7 over 2 minus negative 2, which is negative 1 over 4. Negative 1/4. Question. If you got the same thing but upside down, you put your x's on top, not your y's. Okay, put the equation in slope-intercept form and state the slope and the y-intercept. In other words, solve for y. First step, solve for y. Slope-intercept form is y equals. So I need to get y by itself. First step, move the x's over. Subtract 5x from both sides. Negative 4y equals negative 5x plus 16. I want y by itself. Divide both sides by negative 4. Actually, just divide everything by negative 4. Y equals negative 5 divided by negative 4 is 5/4. Leave it as a fraction. X minus 16 divided by negative 4 is negative 4. You want it in fraction form because when you go to graphing in fraction form is the way you want to do it. Graphing decimals is really hard. Graphing fractions is easy. Bless you. My slope, 5/4. My y-intercept, negative 4. mx plus b. M is slope, b is y-intercept. Okay? Your turn. Okay, so let's do these. First one, subtract 3x from both sides. And I get 2y equals negative 3x minus 8. Divide everything by 2. And I get y equals negative 3/2 x minus 4. My slope is negative 3/2. My y-intercept is negative 4. Same thing here, subtract 2x. And I get negative 7y equals negative 2x plus 14. Divide by negative 7. And I get y equals 2/7 x minus 2. My slope is 2/7. My y-intercept is negative 2. Question? Okay. So write an equation of the line with a slope of negative 2/3 and a y-intercept of 6. So this is mx plus b form. That's my m. That's my b. Y equals negative 2/3 x minus 6. mx plus b. Your turn. This one should be a quick and easy one to do. M, B, y equals negative 4x plus 5. M, B, y equals negative 2/5 x minus 1. Find the x and y intercepts for each. This tells you where it crosses the x-axis, where it crosses the y-axis. If I have this is in standard form. If I have an equation in standard form, this is how I graph my equations in standard form as they're finding the intercepts. Very easy to do, very important to do, but very, very easy to do. It's really easy. To find the y-intercept, let x be 0. In other words, my 2x goes away. And I have negative 3y equals 12. Solve for y. Divide by negative 3, y equals negative 4. That's my y-intercept. To find the x-intercept, I do the opposite. I let y equal 0. When y equals 0, I get 2x equals 12. Divide both sides by 2, x equals 6. Y-intercept is negative 4, x-intercept is 6. Crosses the x-axis, y-axis at negative 4, crosses the x-axis at 6. It's very easy to do. Same idea. Cover up the x's. Oh, that's really easy. Y equals 10. Cover up the y. Ooh, negative 5x equals 10. Divide by negative 5. X equals negative 2. X and y intercept. Let the x equal 0, find the y intercept. Let the y equal 0, find the x intercept. Your turn. Still recording, but that's okay. Really easy. Let x equals 0. Negative 4y equals 24. Divide by negative 4. Y equals negative 6. That's my y-intercept. Let y equal 0. And I get 3x equals 24. Divide by 3, x equals 8. Same thing on the next one. Let x equal 0. X is 0, the x's go away. I get 5y equals 8. 5 divided by 5, y equals 8/5. No problem, not a big deal. So it comes down to fraction. Okay. Let y equal 0. I get negative 2x equals 8. Divide by negative 2. And x equals negative 4. Yeah. So your y-intercept's a fraction. It's not the end of the world. Makes it a little harder to graph. 8/5 is 1 3/5. So it's a little bit more than 1 1/2. So if I'm plotting a point, I go to 1, I go up to 1, and then I go a little bit more than half of that. It's the best you can do anyways when you're plotting points on the graph. You can't be exact. If you want exact, you can use a computer to do graphing. Bless you. Okay. Yep, and that's it.